In this video, we will solve a popular coding interview question using C#. The problem is called palindrome number. We are given an integer, and we need to check whether it is a palindrome. Given an integer x, return true if x is a palindrome, and false otherwise. A palindrome reads the same from left to right and from right to left. Negative numbers can never be palindromes because of the minus sign. Also, numbers ending with 0 cannot be palindromes unless the number itself is 0. First, let's see a simple approach using strings. We convert the number into a string, reverse it, and compare it with the original value. This solution is easy to understand, but it uses extra space. In this approach, we reverse only half of the number. This avoids overflow and improves performance. First things first, let's clear the easy cases. If a number is negative, it's immediately out. Think about it, minus 121 reversed becomes 121, which isn't the same. Next, check if the number ends in 0. If it does, like 10 or 100, it would have to start with 0 to be a palindrome. Since leading zeros aren't a thing in standard integers, the only number that ends in 0 and stays a palindrome is 0 itself. If your input is negative or ends in 0, and isn't 0, just return false right away. Now for the magic. Instead of reversing the whole number, which could cause an integer overflow in languages like C# or Java, we're only going to reverse half of it. We use a while loop to peel off digits from the end of our number x. We grab the last digit using the modulus operator, %10, and append it to a new variable called reverted number. Then, we use integer division to chop that digit off the original x. Every time we move a digit, our reverted number shifts left by multiplying by 10. But when do we stop? Simple, the loop keeps running as long as the original x is greater than our reverted number. Once x becomes less than or equal to the reversed part, we know we've reached or passed the middle of the number. For example, with 12,321, we stop when x is 12 and our reverted number is 123. Finally, the showdown. We compare our two halves. For numbers with an even amount of digits, like 1221, our loop leaves us with x equals 12 and reverted number equals 12. They match exactly. For odd-length numbers, like 12,321, our reverted number ends up with that middle digit, making it 123 while x is 12. To fix this, we just divide reverted number by 10 to discard that middle crease digit. If either of these conditions is true, you've got yourself a palindrome. For example, if x is 121, we reverse half of the number and compare both halves. Since they're equal, the number is a palindrome. The time complexity is O log 10n, and the space complexity is O 1. This method is the gold standard for interviews. It uses constant space and completely avoids the risk of overflowing a 32-bit integer. Efficiency and safety, all in one. If you are preparing for coding interviews, this question is very important. Like the video, subscribe to the channel, and comment if you want more C# interview problems.